Are you able to see my screen? Okay, so we have just discussed about mapping function, that is direct mapping, associative mapping, set associative mapping. In direct mapping, we have used the modulo operation to replace the content, but there are contentions are there. Then we need to go for some trivial replacement algorithm, and that is not the what they have used by tag. They have divided the blocks into tags and blocks and particular word and all. They have used the 16 bits into different category, but that was not flexible. Then we have seen for associative as well as set associative mapping, but they are not that much good. So then we are going for some software based algorithms, and so they are least recently used. So for direct mapping, so this will be quite interesting. Listen, so you will get problems also in this. So for direct mapping, where see, even in operating systems, when we do the virtual memory, we will be studying these. The same algorithms will be used. There are a lot of algorithms. According to your syllabus, only 4 are mentioned. So for direct mapping, where there is only one possible line for a block of memory, no replacement algorithm is needed. For associative and set associative, however, an algorithm is needed. For maximum speed, this algorithm is implemented in the hardware. 4 of the most common algorithms are least recently used, first in, first out, least frequently used, random replacement. Just to understand the what is the meaning of each line. Then when we do the problem, you can understand it easily. This replaces the candidate line in cache memory that has been there the longest time with no reference to it. That is, first they have given least recently used. So we'll see FIFO. So that will be easy for you to understand. Then we'll go for the other types. So FIFO, first in, first out. Pages in main memory are kept in a list. Pages in main memory, they are, see, the same will be used for your virtual memory also. So you can use pages. The term as pages or blocks. So pages in main memory are kept in a list. First in, first out is very easy to implement. The FIFO algorithm select the page for replacement that has been in the memory for the longest time. See, look at here. See, initially, see, there is a reference string. Suppose 7012030 like this. Some numbers are there, right? Are you able to hear me? So these numbers are the memory pages or memory blocks which is being requested by the processor. Initially, so we have seen certain rules here before starting the mapping. If the block, see, if the bit is called valid bit, it is provided for each block. The block contains valid data when the bit is set to 1, else it is 0. Valid bits are set to 0 when the power is turned on. At the beginning, this bit is set to 0. It means the cache is empty. When a block is loaded into the cache for the first time, the valid bit is set to 1. When a block is loaded for the first time in the cache, means before this point the cache is empty. This you have to understand. So 70123. So if you draw one more 3 boxes, this is empty. This is empty. And see here, the processor is requesting for the block or page. I use the term page because I have used the same term, so I use page. So it is 7 is being referred and it is not available. So 7 is, so for the fresh time, when it is freshly loaded, it is not a fault, or it is not a fault or miss. So 7 is loaded. So next, second item. So we are talking about first in, first out. So next reference, ma, Anirudh, Kushagra, or anybody in the class, what is the second reference? Second reference is 0. So it is also loaded. So next reference is 1. That is also loaded. So at this point, the newest frame, the most recent is 1. Now a page reference 2 is coming. Now a page reference 2 is coming. So I need to call the replacement algorithm. So whom I have to replace out of these pages? 7, because first in first out. The one who have come has to be replaced. So 2 is replaced. 7 is moved and 2 is brought inside. Okay. Then 0. Then 0 means there is no need. The searched item is already present in my catch. No need. So when I go for 3, when the next reference is 3, it is a catch miss. It is or page miss. So what I have to do? I need to call the replacement algorithm. My replacement algorithm is FIFO. So tell me who is the candidate for removal?
Ma'am, 0.
0, because 1 and 2 are present. Out of these three, the older is 0. So now 0 is replaced with 1. Next again 0 is coming. Next reference is 0 is coming. So it's not available. Then I need to call the replacement algorithm. Then who is the candidate? Because 1 is the older. The 1 is the older out of these three. So 1 is replaced and 0 is loaded. 1 is removed and 0 is loaded. Likewise, are you able to go through? Shall I repeat the entire thing or you can understand this? Now comes the page reference to 4. Now comes the page reference to 4. What is this? Is it available? Is it available here? 230. Is it available? No. So who is the candidate for replacement? 2 is the candidate for replacement. So because 3 is just loaded, 0 is also just before loaded. So the oldest of these 3 is 2. So 2 is replaced with the 4. Okay, so this is what FIFO. But the problem here, see, here in this reference, the 0 is being often referred, but that is not available. So we are reloading it, or able to understand the data transfer between the page and the, that is the cache and the main memory, or between the main memory and the virtual memory, secondary memory is happening for longer time, and we call this as B-Lady's anomaly. B-Lady's anomaly. Advantage: FIFO is easy to understand and it is very easy to implement, but the oldest block in memory may be often used. The oldest block in memory may be often used, but this is not the exact thing. If not, if this is not an exact drawback or disadvantage. If a block of memory which is being frequently used, which will be wasting the time in transferring. Okay, so next is least recently used. Okay, in FIFO, I'm not using any history. I'm just telling you whoever come first, please move out first. So that kind of algorithm is FIFO. And now I have to worry about if it is recently used, then don't disturb it. The least recently used keeps the track page uses over a short period of time. Understand here carefully. So you have same three frames here, or three blocks. So 701. 1 minute, least frequently. Before least frequently. LFU they have 1 minute. Okay, so 701, this is your reference string that represent the block or page. So 7 for the first time, the cache is empty. All the three blocks of my cache is empty. I am loading the 7, no problem. 0 I am loading, no issues. 1 I am loading, no issues. Now when it comes to 2, which one has to be replaced? Tell me. Now it's time for replacement. When I'm referring, that is I in the sense the process refers to 2701. Who is the candidate for replacement? Our policy is least recently used. Least recently used means out of one is just used, 0 is better than that, and 7 is the least recently used. The time. Okay, least recent. Understand the literal meaning of the word. So 7 is replaced with the 2. Then 0 is, then the 0 is coming. The 0 is available. No need of replacement algorithm. Next 3 is used. The reference is 3. Now tell me who is the candidate? 201. Out of these three, who is the candidate? 1. Because uh, 0 is just used, right? 0 is sorry, am I correct? Yeah, yeah. 0 is just used to come out of these three. The least recent is 3. Okay, so the least recent is 1. 0 to 1. That 1 is replaced with the 3. So 0, it's available, no issues. So again, when I'm referred to 4, which is not being referred for longer time. LRU means the one which is not been used for longer time. That is what least recently means. So 0 is just used, 3 is also just used. So 2 is now is new is not referred for longer period of time, right? So 2 is replaced with the 4. So then 2 is there. Then 2 comes, who needs to be removed out of 403. 4 and 0 are just referred. 3 is the one for longer time which is not referred. So 3 is replaced. Okay, so this is what called least recently used. Actually, in your textbook, in your syllabus, it's been modified. Actually, we have to study FIFO first for easy understanding. Then we have to use LFU, least frequently used. Least frequently used. Look at the diagram. Same example. Yeah. 7012030 same string, reference string. You have 7. You have 7 freshly loaded. 0 is also freshly loaded. 1 is also freshly loaded. Okay. So we have studied something called value bit, right? Value bit is set to 1 means it is available. If it is not available, then we'll say as b is equal to 0. No matter. So 7 0, then 1 you can give. And what is this FFF? Fault. This is called page fault. That is whenever a item is searched, if it is not available, we used to say catch miss. And this PPT have been done with the because these concepts are used for virtual memory concepts also. Okay, there we, instead of catch miss, we say page fault. If item for which it is not available and it is being loaded, it is yet to be loaded means, then we call it as page fault. If it is available, then we call it as page hit. In the previous examples, they have counted the hit. That is, hit means the item is available. And in this particular example, they are giving the pointing only false. The false means fault. Understand this. Don't get confused. This is about page fault. That is about page hit. Okay. Then 201 available. 701. Yeah, 701. Then 2 comes. Then 2 comes. Who is the candidate? Who is the candidate? When 2 is there, who is the candidate for replacement? Here in LRU, we have used this side. Whereas in least frequently used means we have to worry about the future. See here, 0. Out of these, in this direction, you have to check. 7 is being referred for long, very long future. Okay, so then 7 is replaced with the 2. Then 201 page hit, no problem. Then 3. So then 3 means who is the candidate? 201. Who is the candidate? 0 is referred immediately. 2 is referred immediately when compared. So 3 is not referred for a longer period of time. So 3 is replaced. Likewise, are you able to understand least frequently used? See, for FIFO, the same order, first in, first out, no matter whether it is faster or older. Whereas with LRU, least recently, you have to worry about the past. That is, past references you need to understand. You need to mention how old they are. Okay. And whereas with LRU, what you have to worry about is how long they will take time in the future, how older they are in future. That is, you have to check along this way. Oh my god. For a least frequently used, you have to check the age by that direction, and whereas for LRU you have to check the age, how older they are by this direction. Okay, so other theory things you can go ahead. And the other method, random replacement, there is no need of any specific algorithm or format. Simply you can randomly change. But you can easily make bad choices by swapping out pages right before they are needed. That is the drawback of random replacement. But there won't be need of time to execute the replacement algorithm, because the random replacement algorithms also some programs only, they also need some time to decide upon the replacement. Okay, with random replacement, that is not aware, that time is not wasted, but there will be a lot of waste. What to say, wrong decisions will be taken on replacement. Okay, so next we'll see in next class. So thank you for your cooperation and for your patience.